Hi, all curious minds. In a previous video, I was talking about what can you do when you find a security vulnerability. In this video, I want to cover the other part. What can you do if you receive one? And before I continue, I have to mention security is huge, and this is why I will not cover every aspect. To give you some idea, I figured I should define four categories that I want to talk about. The first we call third party vulnerabilities. So the third party vulnerability reports. The second, well, if you are in IT, you're developing a code, then probably you heard about static code analysis. Where is the third is when you actually receive a report in the form of a support ticket, a customer or an ethical hacker send you an email about they found something. So it's an actual report. And the fourth category I want to mention is, well, when an actual incident occurred and you have to deal with the consequences. So this will be our agenda. And for bonus, plus one, some tools. Okay, so let's start with the third-party vulnerabilities. Well, I want to mention this because I was surprised that many IT professionals in higher roles are not familiar with the term and what it's called, like CVE, the common vulnerability exposures. It's a collection about known vulnerabilities. It's a similar concept, the CVE, the common weakness enumeration metric. And we can talk about NVD, the National Vulnerability Database. So my friend actually received a CVE, some number, and he asked me that, "Hi Zoltan, can you explain me what this vulnerability is about and what to do with it?" Well, I digged into the details, but he actually wanted to know one thing: what to do with it. Always upgrade. If you receive a report with an assigned CVE number, with a national vulnerability database number to it, you should upgrade the package. This is the number one thing you can do. And why I'm saying this. Many of these reports are under, well, what I call is the public I don't know this word, disclosure process. What this means? Well, if ethical hacker or someone who finds this vulnerability, then they try to find a connection with the project, with the team, with the company, and they try to resolve this issue inside of their own organization. So it's a private process in the start. But when they find the actual weakness, they usually fix the code, release a new product, and they publish this vulnerability to the public to, well, make your customers aware of this issue, that if they are still running this code in the previous version, then they probably need to upgrade it, because it contains a vulnerability that you should address. So at least 90% of these reports has a fix available to it. But not always this is the case. This is why I talked about in the previous video. For the purpose of this process is to limit the scope of knowledge. So we want to limit the scope of knowledge. If there are a vulnerability in our code, in our organization, then probably we don't want to, well, tell the whole world about we have some security issue, because it will impact our business, it will impact our customers, it can cost us money, time, reputation, and so on. But what if the project is not receiving enough funds, so developers are not able to address the issue, or the project is abandoned and there are no developers who can fix the issue, or they are not willing to, well, fix the security issue, then you have this concept to unlimit the scope. This is an ethical hacker responsibility. If there are serious security issues that are not addressed, then you basically force the company, the organization, to fix their security issue. If they are not willing to fix it, or there are no maintainers who can fix it, basically you're going to go to public, and persons who are using the software will be aware of that vulnerability there in that code. So I hope this is less than 10% in the time. what can you do when you, well, receive something like similar like this? You should, well, switch to another provider. That's the only resolution. If the software component that you are using not receive a security patch, then you should consider of switching to another provider, because nothing is new, not in the IT, not in the world. Everything is just rethinked, and there are many alternatives to a problem. You can switch to another programming language, to another cloud provider, to another operation system, or another software component which can do the same. Okay. But here comes the issue. What happens if I try to upgrade the code? Or when I try to switch to another provider? Then usually what I see and heard from developers, from organizations, is the code or fancier, the product will break. Yeah, this is a valid issue, because when I upgrade the code or switch to another provider, then the existing code may break. The point here is may. And to mitigate this issue, you should invest in, well, tests. Testing is a, well, not easy task. So you will have the QA team to do their manual testing and so on. You don't want to go to the QA team, because the issue is with the software component, so you need to invest in unit tests. If you have unit test coverage for your code, then you can upgrade the software components without hesitation, and the code will still work, or it will break on the unit test. But you will know which test was broken by the upgrade. And with it, you will be able to resolve the security CVE issues much faster. So, the solution to fix this issue is to upgrade or switch. Wouldn't it be great if there was a software that could help us automate this process? And there is. There is a tool called Dependabot. which will check your software for CVEs, and if there are an upgrade for a package, it can automatically create a pull request with the upgraded package configurations. So you only need to accept the pull request and your code will be fixed. And you can create additional pipeline steps to mitigate this issue, solve this issue. So CV number, you see the CV number, invest in Dependabot, upgrade your packages or switch to a new provider, and you're done with third-party vulnerabilities. Okay, let's move on. Let's talk about static code. Analyze this. I've worked in many organizations who were investing in static code analyzers. I'm not against them. But many of the time, these static code analyzers are just making noise for the developers, and they are, well, overwhelmed with their reports. And usually, they are not aware of what to do. So you need to be very picky about how you are threatening these kind of reports. Just some hints that I introduced to some organization and some of my own projects. One is to don't use else. So in our code, when we try to code something, then we have this option to use the else statement. If something happens, then we can else do something else. Every else statement in a code can be refactored to use not to use. Okay, sorry. Yeah, if you want, you can. Hey, Tiny. Sorry. You can refactor your code to not to use else statements, and you can learn about this concept. So this is a very easy one. One of the benefits of not using else statement, it will force you to write functions. So use more functions. So if the static code analyzer point you to a big globe of code, then what you should do, well, you can extract that code piece to a function and call just that function. And with it, you can, well, reuse your software component and many, and it will limit the scope of that report. And it also reduce a lot of static code analysis issues. So now we have more functions. Then the third is going to be very familiar. Unit tests. In another previous video, I was talking about the importance of unit tests and a metric code coverage. If you don't use else, you use functions more often, and I forgot your function should be, well, it's not a rule of thumb, maximum 30 lines. Just to the reading volume of a function, but they basically need to do one thing. If you use else in your code, then basically it will not doing just one thing. It will every time will do if this happens and else. So it basically use two different things that are not advisable. And if you are focusing on functions with less than 30 lines, or basically a function with doing only one thing, then you are better doing your job. And the third part is the unit tests. And you should focus on code coverage with unit tests. And at least you should be aiming for 80% code coverage. I know there are a lot of people saying that 80% code coverage means nothing. For me, it means that you are not writing unit tests. And if you are not writing unit tests, it's a security issue. It will be, well, shown in the static code analyzers, because one of their metrics is, well, what is your code coverage? So it will also fix a static code analyzer issue by introducing test coverage to your code. Unit tests will also force you for better practices in your coding style, like dependency injection. Like dependency injection. So a database connection, a database type should be a dependency to your code. And with it, you can make better functions. And if you switch to another dependency, then another database provider, then your code will still be good. The static analyzer will not scream for your changes, and you are also good to go. And dependency injection is quite common to understand. Magic numbers. What are magic numbers? Magic numbers are, well, static code pieces in your code containing a simple value that maybe could be a predefined array, a configuration, a configuration piece, or sometimes, quite commonly, there are secrets like database access are embedded in the code, and they shouldn't be there. And that's a static colonizer issue that will show you that, well, you should focus on magic numbers. And basically, this is configuration. And this configuration can be injected with dependency injection. So, if you want to reduce your static colonizer issues, a simplest tip, don't use else. If I see in a code an else statement, I assure you there is an issue with your coding style. Probably you are using more than one thing in your functions. And if you are using more than one thing in your functions, you have hard time writing unit tests because you are not using unit tests. Probably you are not, know how to inject dependencies to your code pieces. And probably I will find magic numbers because to get around this issue, you will be, about dependency injection, you will put magic numbers into your code. And the worst case scenario, it will be a secret, like a database connection or a password. Okay. So, the third, an actual report. So, now we have an actual report. Somebody found something. And we need to figure out if this report is actually valid. Some may heard about the CIA triad. It's not the CIA as the government agency. It's stands for confidential integrity and availability. So this is a framework to help you to identify how crucial a vulnerability can be. Are you sorry about this. My camera think that it's time to sleep, and I had to recheck the recording. So the CIA triad. It stands for confidentiality, integrity, and availability. And this is a framework how you could, well, categorize security vulnerability. But this is a security standpoint. So this is a security metric. When we are talking about vulnerability, well, probably there are more than one person or more than one team unit will be involved. So I tried to explain this to devs. So, what could be confidentiality? It's a GET request. Who can get the data? Integrity. So, integrity, who could post? Who can add new data to the dataset? And in a developer's perspective, availability is, well, not really a concerning part. We can write, well, high availability functions in different kind of software technologies. But to be simple, this is the delete request. So we could try to find if this security report, an actual report, which part of our code is violated by. Is it exposing some information or letting the attacker put something into the code, or they are able to, well, delete something that they shouldn't supposed to do. But the code is usually run by ops, operation guys. And here comes, well, a bit difference. I don't know if you heard about the CAP theorem. Well, we can consistency. So confidentiality could be, well, matched to if the data is consistent for those who's, well, supposed to have it. We can go to partition tolerance. So if a server goes down, then the data is still available somehow. And availability, sorry, it's still available. It's still availability. But what we can know about CAP theorem, it's mathematically proved it cannot be achieved 100%. So this means whatever you do, there will be a security issue in your organization or in your code, in your product. No matter what you do, there will be a security issue. So we could try to use the CIA triad, Capteurum, security training, learning, and other stuff. But we have an actual report. Maybe it would be more easier to resolve an actual security report by asking just one simple question. Is it harmful? Is it harmful? Can it make any damage? So, okay, I received the security report, but can it make any damage? What damage can it cause? Well, reputation. So I receive a security report and I'm not addressing it, and it's leaked to the public. Can it harm my project, my company, my organization reputation? If it's not, well, it's not a security issue. Well, many of us think as a security issue as will I lose money? Will my customers lose money? Is it connecting to money or something similar like that? That's one of our obvious metric about a vulnerability, how much money it will cost us. Many of us are not thinking about, but there is a more precious resource that a security vulnerability can address, and it's time. Like if we are trying to, think about the denial of service attacks, many of the time it will cost time, not just resources. It will cost time, time to resolve the issue, time to notify our customers, time to fix our code, time and time and time, and most of the time this is more costly than just simply money and our reputation. And it can affect our user experience. Think about, the less harmful attack that a user can experience, like a site defacement. Like you have a website, and with a vulnerability, they change the color or something like that. Pray for this kind of attack, because it can influence the user experience, but our service, our project are used by users. So if their experience is damaged, then it is a security report that you should address somehow. But let's move on and how to try to address it. Actually, The first step, you need to have a forum. Where customers, ethical hackers, responsible person can send you a security report. The only purpose of a forum, I'm not meaning actual forums, is a place where you can create and send issues which will resolve in a ticket. The second step should be, you should be able to create a proof of concept. Why this is crucial? Because if you don't have the necessary skills to reproduce an issue, okay, you cannot create the proof of concept script, a code, then you cannot write tests. Why I'm leaving this gap? Once again, are you writing unit tests? So, I have an actual report. I can reproduce it with a proof of concept. How will I know that this issue is actually fixed? By testing it. How can I mitigate the reoccurrence of this issue? I write a test, not just pushing a button. You should actually write a test. And where you can start writing tests, you can start just with unit tests. And you have unit tests, which will resolve in the static code analysis, and as you can guess, it may be resolved as just upgrading the third-party vulnerabilities. So this is why I'm talking about why unit tests are so important for security. I know this is going to be a long video, but now we are at the part we have an actual incident. This is the worst case scenario. You should try to eliminate this effect by shifting left with your code development cycle, with your production cycle. Shift left is the way to go. But we have a security issue. What the first thing you should do? Well, just a humor. 42. The hitchhiker guide for, don't panic. The first thing you should focus on, don't panic. The damage already done. You should be somehow learning about this and figure out a way to resolve this and not make sure it will not happen again. At this point, many organizations are don't blame. So there is a security incident. and we are trying to blame who was responsible for this issue. The simple answer is the hacker. The hacker was responsible for the attack. Not your developers, not your operations, not your colleagues, the hacker. A hacker can be inside of your organization, maybe, but that's a different kind of stuff. So don't blame your team. I see many people, when it comes to security issues, blame the devs. Because we released a software with a vulnerable code on it, but actually what you should know that the code wasn't. The code wasn't exploited. How could it be? The code is just the text. The text from a TXT file, for example, or from a Markdown file, well, it needs to be interpreted somehow and deployed to a server, or it may be end up on the client side. So we have a security incident. Don't panic. Don't blame. The incident happened, and it can be happening on the server or on the client side. So on our infrastructure or code that is available for users to work with it. And now we know what to do, and here is another security concept. People, tools, and people, tool, and processes. Now, we have an idea. This incident happened. So the root cause may be actually in our code. Well, we can train our developers to do their job better. How they can do their job better? Well, probably they need some automation. To enable this automation and allocate resources to it, you may need to invest in some of your processes. These processes will guide your people, maybe inspiring the operation people to introduce new tools that will be able to identify different kind of security issues, which will lead into other processes. So this is people, tools. Okay, sorry. Processes, which will so this is an infinite cycle. And in my experience, when this happens, you should somehow invest in the monitoring. But not for CPU metrics, memory metrics, or similar like that. But to figure out the access control. Because somebody had to do some damage. And if we're investing in monitoring and access control, this may result in some security tools. This is back to this infinite cycle. If something happened, maybe a person involved, actually a hacker is the person that was involved in this cycle. We invest in monitoring, a tool, which resolve in our processes, like creating a security policy or something like that, that will help our developers, our security admins, or HR, or anything other to solve their needs, which resolve in other tools like defining a correct access control, which will resolve in a new process. Then people will try to work with it, which will result in investing in security controls. So this is the reason why I'm a fan of the monitoring and metrics. It can show you quite a lot of things. So now I talked about tools. Security tools. I've got this a lot. So if we have an incident, we should, figure out a way how to mitigate further incidents. And what should we do? We should buy an expensive firewall, we should invest in ISO, or we should invest in very expensive stuff. And actually, nope. You need a secret manager. So any kind of tool that helps you to, create and share secret informations, passwords, access token, and something similar like that, you should invest in it first. And you should be able to protect it with two-factor authentication. Not your application, the secret manager. Like a hardware security key. So if somebody wants to get access to your secret manager, where you create your secrets, your passwords, your access tokens, and try to share it, you want to protect that single source of truth of secrets with a 2FA. Not with your mobile, but maybe with a hardware security key. I talked about it earlier, but the number one security vulnerability on the OWASP top 10 is the authentication part, like the access control. And many of the concepts around the security is like how you handle passwords. I say avoid passwords. Figure out a way how to avoid passwords. Maybe you introduce a secret manager and it will create randomized passwords every couple of weeks. And you may not know any passwords, or you use a hardware security key or some other methods just to avoiding passwords. If your users don't know passwords, then a hacker is not able to store your passwords. Simple as that. Simple, is it? And monitoring. So, every security aspect has one common in there. It's monitoring. Like figuring out different metrics. And here I'm not talking about CPU or memory usage metrics. It can be a great indicators of an attack for DDoS or scalability for business users. But in a security standpoint, they are probably not a good metrics. You should monitor the access control. Who using what and why? So this is for access control. And there are some tools that offers access control languages just to, help your day. And fourth, let's see. Workflows. Sorry. Yeah, I know this concept security tools can be misleading. I don't want in this video to talk about the actual tools and products. These are concepts. What I mean about workflows is how you process your logs. If you're monitoring, you should monitoring your logs. If you are able to monitor your logs, then you have a knowledge about who using what. And you may be able to invest some in a web application firewall. Now every server or many of the business has a web application that needs to be protected, and a web application firewall is a good thing to have. Okay. Okay. Oh, yeah. And with it, you will be able to identify and block an attack before it can reach a vulnerable code piece. And if it actually reach it, well, you will know who was and when was and what they achieved with the attack. These are the, well, quite obvious security tools, but here comes a little funny part. Many people are not considering pipelines as a security tool. Continuous integration, continuous development pipelines. This is the number one place where you can start actually protecting your infrastructure. If you have a great solid pipeline, then many of the security issues that may occur can be solved with a great pipeline. Six. For a pipeline to work, it needs tests, quality gates, and unit tests. This is why I said it's crucial to have. And 7, a lot of the person I know are not aware of that a documentation is actually a security tool. Why? If you introduce a new security concept, how you're going to tell an employee or customer that you are using this kind of security approach if it is not documented? Okay. So this is why I say that these are not obvious security tools like pipelines, unit tests, and documentations, but they are quite of the foundation how to solve a security report that I received. So I hope you learned something about this video, and it will guide you how you can proceed different kind of security reports in the future. I was Zoltán Toma, and this was the Curious Minds Collective, and see you in an upcoming video. Bye!